Hello, everyone. We are Group 1 and we chose the mechanics of a vortex within a beer bottle. What we did is that we applied an experiment. And our experiment was basically that we had two people pour a beer bottle down. One of us poured it normally, and the other person twirled it while pouring it down. The first 3 seconds, we would say maximum. We found out that the person who twirled it, it took half of the time to pour the beer out of the bottle rather than having it static. Our observations were also taken from the link you can see here. There are people who also did the same experiment, but they did it twice separately and they calculated the time. So the hypothesis we built on this experiment was that the flow from a bottle is twice as fast when the bottle is being twirled compared to a standard pour. We later then applied our hypothesis on our observations and the way we analyzed our topic. The way we analyzed it is we applied Bernoulli's equation after writing the things that we saw and the way we analyzed the topic in hand. Both the beer and the air within the bottle occupy an initial volume at initial pressure. Due to carbonation of the beer, the air pressure within the bottle is naturally higher than atmospheric. Once the cap is twisted off the air, pressure within the bottle equalizes to atmospheric pressure. Hence, you can hear the sound effect when the top is removed. As the bottle is flipped so that the neck is now facing downwards, the beer falls towards the neck and the air isn't pushed out, is then sealed off by a beer carrier. As the beer falls out of the bottle, the air pocket is expanding, creating vacuum. Once the pressure is low enough, atmospheric pressure punches its way through the barrier, equalizing the pressure yet again. However, this operation is cyclic and thus gulping continues until full displacement. After this explained hypothesis, we came to see how would we analyze the situation, how would we observe it. We asked ourselves, why does the beer even fall out? If water out of a closed straw stays, is the pressure drop too severe and thus it falls out? We asked ourselves many questions and then we came to analyze the situation. That's when we saw that if we swirl the bottle and we spun it fast enough, flow becomes an open channel as momentum pushes the beer against the walls of the bottleneck, constructing an air channel through the middle of the stream. And so we use the Bernoulli equation that describes the mechanism of our hypothesis and why does the vortex behave the way it does. We analyze the process by taking two beer bottles as mentioned, and opening them at the same time and calculating the time and seeing which one takes less time. As mentioned, it took half of the time when pouring the bottle and twirling it at the beginning. So we compared the static versus the twirling. Our conclusions were very basic. We saw that if we twirl the beer initially, the beer flow takes almost half of the time because we create an open channel that creates a pressure that equalizes and makes the flow rate much quicker rather than having a normal flow of a bottle that creates a pressure against the flow of the fluid, which causes more time for the flow to take place. Then we go ahead to explaining to you how did we apply the Bernoulli equation and how did it relate to our topic. We used the Bernoulli equation to calculate our velocity when we had the open channel, which is basically when we twirled the beer bottle, and we found out that the velocity was 2.12 seconds. 2.12 seconds, which is much less than the velocity of having a static bottle pouring down. And so this was our topic. We chose the pouring a beer bottle. We found out that if you twirl it at the beginning, it will take much less time. We used the Bernoulli equation to prove our hypothesis and our conclusion. And here are some of our resources that we used. And thank you so much.